Let's now talk about deployment in cloud. Up till now, everything we've done with Kestra has been on our local machine. So our operations, including our advanced, dynamic backfilling and incremental loading, as well as our parallelization, are all limited by the capacity of our local machines. So if you want to overcome those limitations, then deployment in the cloud is the next step. The cloud provides a more scalable and reliable solution for our workflows. They provide less operational overhead, and they give us a platform in which it's easier for teams to collaborate with each other on. And finally, it's very cost efficient. You only pay for what you provision. Kestra offers a lot of options when it comes to installation in the cloud. In their main docs page, you can see all of the provided options that are cloud-based and on-premise based. So as you can see, there are options for AWS, for GCP, for Azure. So if you're interested in deploying your Kestra project, it really doesn't matter which cloud provider you use. There's a pretty straightforward way for any of them. So I personally already have GCP set up, so I'll be using that for our setup here in this demo. More specifically, I'll be following the instructions that are provided in this page here, where we set up our Kestra project in a GCP virtual machine. Okay, so let's get started. As you can see, we're in our GCP console. So I'm going to head to our VM instances page, and here I'm going to be creating our virtual instance. So I'm just going to call this deploy Kestra app. And for the region, I'm going to switch this from US Central to somewhere in Europe, Berlin, since that's where we're based. For machine types, I think E2 will be sufficient, but Kestra is going to need slightly bigger instance type, or RAM at least. So 2 vCPUs and 8 GB memory is going to be enough. Now on the left, I'll switch over to OS and storage and click on change. We're currently in the Debian operating system by default. I'm going to change this to Ubuntu, and instead of the minimal version, I would prefer to just go for the regular. There we go. And to set up the Kestra server, we'll need something a bit bigger than 10 GB, so I'll just make this 20, and I'll select. For data protection, I think I can leave everything as is. For networking, we'll allow HTTPS traffic. We'll leave observability as is. Same with security, and same with advanced. So I'm gonna create our instance now. And let's wait for this to finish loading. So as you can see, our Kestra VM instance is up and running. We can now access it directly by using SSH. So I'll click on this. And now we have access to the terminal of our instance. So before we can, go ahead and start our Kestra server, much like how we did with our local deployment, we actually first have to set up Docker. Because if I currently were to check our Docker, you'll see that, the command's not found. So let's first install our Docker and Docker Compose before we actually get started. So I'm going to say Ubuntu Docker install. I'll click on the first option, and on the bottom, you'll find a bunch of the CLI commands you need to do in order to set up Docker and Docker Compose. So I'm just gonna copy and paste all of these. Okay, after our copying and pasting, we should have Docker access. So let me perform the same command again. This time we can see it's up and running, and we'll do the same with Docker Compose. And that's running too, great. Now I'm going to start up our Kestra server the same way as we did before. First, I'm going to use the curl command to download our YAML file. And now you can see that we have our YAML file. Now all I'm going to do is I'm going to do sudo Docker compose and up. So I'll avoid the D flag now because I just want to show you the logs. So if I click this, let's give it a minute to load. Okay, the fact that you can see our logs is a sign that the setup has completed without issue. So we can move on to the next step. So if you recall, during our local deployment, once we did our Docker compose up command, we were able to directly access our UI through localhost, the 8080 port. However, we won't be able to do that here because the cloud is quite different. And to show you what I mean, I'll just give a quick example. So next to our virtual machine, we can just copy our external IP. And if I were to add 8080 to it, that's not 8080. If I were to add 8080 to it, you'll see that there's nothing going on. And the reason for that is quite simple. So GCP, by default, its firewall will restrict access to our Kestra app. So this is a good security measure, but we now want to allow our, we want to enable access to this port. So all we have to do is just to make a small adjustment to our firewall. And the way to do that is very simple. So I'm going to go to the ellipses next to our virtual machine. I'm going to not delete, I'm going to go to view network details and go to firewall. And here I'm going to create firewall rule. Here I'm going to give this a name. I'll call it Kestra firewall rule. I'll leave a lot of these config as their default values. For targets, I'll just use all instances in the network. It's fine for our demo. And for our source filter, the IPv4 ranges, I'm just going to say 0000/0, so just allowing access from everywhere. And for the protocol and ports, I'll specify the protocol. I'll select TCP, and this is going to be 8080. So this isn't random, of course. If you recall, in our Cloud Compose YAML file, we set our port to be 8080. So we'll be doing that here as well. And we'll create. Great. So our firewall has been created. It's called Kestra firewall rule. Now I can head back to our VM. And now I'm going to do the exact same thing. I'm going to copy our external IP, paste it, and do 8080. And as you can see, this time we are able to see our UI. Well, right now I have to create my own account. Again, this is nothing new, so I'll do that very quickly off screen. Now I can quickly log in. And there we go. We have our Kestra UI available through our cloud instance. So everything that I do from now on has already been done in our local deployment and it's already been explained. So there's very little to really talk about. So I'm going to be redoing a lot of my steps, such as creating or uploading my Python file here, creating storing my values in the KV store, and then writing and executing my flow. So let me do that very quickly. First, our Python file. So here's our Python file. Now for our KV store, let's just add our credentials here. There we go. Everything has been added. And finally, our flow. Now that I've added everything, let's execute our flow and see what happens. And that's it. As I hinted at before walking you through cloud deployment with GCP, the solution that I showed was pretty bare bones. It was pretty, minimalistic, and it's something you'd expect from a demo or a proof of concept, but not something that you would expect from a production level, setup. So here I just wanted to quickly talk about things that you could add or change if you really want your project to reach that level with Kestra. Well, the first, of course, is you can use services from cloud providers for the Postgres database. And what I mean is currently, if you recall the Docker Compose YAML, when you spin up your Kestra instance, it comes with a Postgres database that stores your flow data and other metadata. Well, rather than using that built-in database, you can actually uh, allocate that work to a Postgres instance provided by a cloud provider. And what that does is basically it makes your solution more scalable. So for example, with GCP, you can use Cloud SQL. And as a matter of fact, the Kestra docs actually does show you how you can do that if you are interested. But this is something you could do for, any of the cloud providers. Then you can also use identity and access management for access control, which we didn't really touch upon. You can also run Kestra with Kubernetes. So rather than using a virtual machine, which can be, relatively fragile, you can standardize your deployment with Kubernetes. And finally, you can use a secret manager of some kind. It's going to be a lot better in terms of security for storing your credentials as compared to, the KV store that we used in this demo.